Welcome to this explainer. Today, we are embarking on a truly thrilling descent into the absolute deepest, most mysterious parts of our own planet. We're talking about exploring Earth's ultimate frontier. It's a place defined by total darkness, freezing temperatures, and literally unimaginable pressure. The data we're about to unpack is going to fundamentally change how you view our world. It's a journey that takes us way beyond the limits of sunlight, far below the reach of everyday tech, into alien landscapes hidden right here on Earth. So let's begin the descent. Okay, I want you to really let this number sink in for a second. 0.001%. Despite every single modern technological advancement humanity has made, we have seen less than this tiny fraction of a percent of the deep ocean seafloor. To put that into perspective, the total area of the deep seabed that explorers have actually laid human eyes on is roughly the size of the state of Rhode Island. That is a staggeringly small footprint, especially when you realize that more than 90% of our ocean is classified as the deep ocean. It's this vast, hidden wilderness just a few miles beneath the waves. And honestly, it's incredibly ironic because we can point radar and lasers at neighboring planets from orbit without any interference. We actually possess better, higher resolution topographical maps of Mars than we do of the world sitting beneath our own oceans. We literally know more about the surface of a dusty planet millions of miles away than we do about the bedrock of our own home. Why? Well, water itself acts as a massive barrier, absorbing the exact electromagnetic waves we normally use to see and measure things. Which brings us to Section 1, Earth's greatest unexplored frontier. The absolute deepest frontier on Earth is known as the Haddle Zone. Dropping from 6,000 meters all the way down to 11,000 meters, it's appropriately named after Hades, the Greek god of the underworld. But this zone isn't just one giant continuous bowl at the bottom of the sea. It's primarily made up of widely separated tectonic trenches and troughs. When you combine them all, these extreme Haddle regions occupy a total area about half the size of Australia. It is Earth's true aqua incognita, a series of deep cuts into the crust, holding secrets we're only just starting to uncover. Fortunately, that veil is slowly lifting. As of April 2026, thanks to the incredibly ambitious Seabed 2030 initiative, we have officially mapped 28.7% of the global seafloor. We're doing this using modern, high-resolution, multi-beam sonar, basically bouncing sound waves off the bottom to create a highly detailed 3D picture. It's a massive leap forward from the old days of just dropping a weighted rope over the side of a boat and guessing the depth. But still, it leaves over 70% of our seafloor as a complete geographical mystery. Moving on to Section 2, Surviving the Crushing Depths. A talented mechanical engineer can usually figure out how to build a heavy, watertight box. But physics fundamentally limits what we can do in the deep ocean. The constraints are absolute. Down there, you have zero GPS and no wireless radio communication because radio waves simply don't travel through deep water. And visible light? That's entirely gone after just 10 meters. Combine that total sensory deprivation with near-freezing temperatures and crushing pressure, and you've got the most hostile environment on planet Earth. Dr. Jean Carl Feldman, an oceanographer at NASA, actually hit the nail on the head with this. He noted that in many ways, space travel is actually easier than deep ocean travel. Think about it. In space, you can communicate seamlessly. You have a line of sight for literally light years, and you're dealing with a vacuum, which means zero pressure. The ocean is the exact brutal opposite. You're constantly fighting against the immense, crushing weight of the water above you, all while completely blind and totally cut off from the surface. So just how extreme is that pressure? Well, at the bottom of the Mariana Trench, nearly 7 miles straight down, the water pressure is over 1,000 times greater than what we feel at the surface. Imagine having the weight of 50 jumbo jets pressing down on your body all at once. 50! That is the visceral, terrifying reality that our submersibles and scientific instruments have to survive just to take a single photograph or grab a single scoop of mud from the abyss. Section 3. Tech Navigating the Abyss. Our journey down has been marked by some pretty incredible, hard-won milestones. Back in 1872, the HMS Challengers started systematic exploration using really rudimentary-sounding weights and dredges. Jump forward to 1960, and Jacques Piccard and Don Walsh actually survived the descent into the Mariana Trench in the Trieste bathyscaphe. Then, in 2012, filmmaker James Cameron completed a historic solo dive. And by 2021, we entered a totally new era, successfully testing the Orpheus autonomous underwater vehicle specifically designed to systematically survey these hadal zones without risking human life. And that brings us to the cutting edge of exploration today. We're now developing incredible robotic systems for that Seabed 2030 project I mentioned earlier, like autonomous mapping barges and the SeaKit uncrewed surface vessel. These autonomous crafts can literally launch from shore, deploy their own underwater vehicles to map the ocean floor, and return massive datasets, all entirely without a human crew on board. It's a real game changer because it drastically reduces the massive costs and logistical nightmares of manned research vessels. Plus, we're moving from deploying single vehicles to utilizing synchronized swarms. Heterogeneous multi-robot systems, which just means teams of surface and underwater robots working together, are learning to navigate dynamically. Because they can't rely on GPS underwater, they're programmed to make onboard AI-driven decisions. They adapt their flight paths in real time to track biological features or map the seabed without needing a pilot on shore holding their hand. It's a total paradigm shift for oceanography. Section 4. The deep sea mining dilemma. So, down at the bottom, we find ourselves caught in a profound debate between technological promise and environmental morality. On one hand, the deep sea contains vast, untouched deposits of copper, cobalt, nickel, and rare earth elements. These are the critical minerals we desperately need to build batteries for renewable energy and fight climate change. On the other hand, extracting them comes with a steep potential cost: the risk of irreversible habitat destruction, the loss of uncatalogued species, and the creation of massive toxic sediment plumes. Researchers are raising some pretty severe environmental warnings, pointing out that the deep ocean is Earth's largest and least understood ecosystem. Their big concerns are that massive mining vehicles will crush slow-growing, highly specialized benthic habitats that could literally take centuries to recover. Plus, the extraction process stirs up toxic sediment plumes that could smother marine food webs. There's also the fear that artificial noise and light will disrupt animal navigation, and that disturbing the seabed could release stored carbon, which might undermine our global climate regulation entirely. Section 5. A race against time. The regulatory framework governing all of this is, well, incredibly tricky. The United Nations has actually declared the deep seabed the common heritage of mankind. However, the governing body, the International Seabed Authority, is currently wrestling with a conflicting dual mandate. They are tasked with both licensing commercial mining contracts and protecting the ocean ecosystem. Because of this inherent conflict and our severe lack of scientific understanding, many experts and international organizations are now calling for a strict precautionary moratorium until we actually understand the long-term ecological impacts. Which leaves us with this final, incredibly powerful question to ponder. Should we risk destroying Earth's last, virtually unexplored wilderness to extract the very minerals we need to secure a green energy future? It's a profound ethical dilemma, pitting human need directly against ecological responsibility. And how we answer it is absolutely going to shape the future of our planet. Thank you so much for joining me on this descent through today's explainer, and keep your curiosity exploring.